right, gentlemen. So I just wanted to go through a couple examples from the worksheet, the Graham's Law worksheet. I assume the Dalton's Law worksheet's going okay. Most of you can probably add or subtract. If you have any questions about that, though, feel free to ask during the daily check-in time or email me. So I'm going to do one example, and then I'm just going to talk about how to do some other ones that might be a little confusing if you don't realize how they're worded or what they're asking exactly. Uh, Again, just to be clear, these are all from the Graham's Law worksheet. Graham like the cracker. So, the velocity of fluorine gas at 25 degrees Celsius is 25 meters per second. What is the velocity of chlorine gas at the same temperature? So we're looking for a velocity. So it's going to be, and again, Graham's Law is rate A over rate B equals the square root of the molar mass of B over the molar mass of A. It's very important to remember that you have to invert A and B. So if A is on the top in the rate, it has to be on the bottom for the molar mass. They're inverted. That's Graham's Law. Like, you can't just not invert them and expect it to work. It won't. That's the wrong equation. So I like to set my unknown to be in the numerator. In this case, my unknown is a rate. Meters per second is a rate. So I'm going to set X up here, and that's the rate that goes with chlorine, because that's what it's asking about. Chlorine, remember, Cl2. That's going to be important. And then fluorine happens to be 25.0 meters per second, and that's with F2. So we will plug those into the equation, and all we have to do then is get the molar masses, plug them in, and solve the equation. It's not too hard. Just make sure the molar mass for chlorine is going to be on the bottom, and the molar mass for fluorine is going to be on the top. Otherwise, you will have gotten the wrong answer. Okay, so I plug the two molar masses in, again, making sure to invert them. So chlorine is 70.9 grams per mole, and fluorine is 38.00 grams per mole. These are gases, and just remember, a lot of common gases are the Brinkelhoff gases. So chlorine is F2, or chlorine is Cl2, and fluorine is F2. So just make sure that if it's one of those, you do in fact double it, especially when you're calculating the molar mass, or you'll be wrong, which is not ideal. So the first thing I did here, since we have all the numbers under here, I just calculated this value. There's no point in like squaring both sides. I just calculate the value, and what I got is 0.7321. And I used 4 sig figs because everything I was using to calculate that value had 4 sig figs. It's not super important, but it is the correct way to do it. So I just brought down the x over 25 equals 0.7321. At that point, you multiply both sides by 25. I didn't show that step, but I assume you guys can do it. And you find that x equals 18.3, and it's meters per second. And I put chlorine, that it was for chlorine gas in parentheses there. But 18.3 meters per second. The reason I went to 3 sig figs here is because 25.0 only has 3 sig figs. So that would limit us in that situation. So that's 18.3 meters per second. Nothing super complex there. Just remember, use your calculator to calculate the square root. It's not like you have to do anything with this. It's super complicated. Just calculate that value. And that's it. So there are a couple, I'm not going to work through any more problems completely, but there are a couple other things I wanted to talk about. And that's the wording and how you would do something like this. So compare the rates of fusion between nitrogen monoxide gas and carbon monoxide gas. So whenever it says compare, all of these things, there's no set rate for these things. It depends on the temperature. The higher the temperature, the faster these things are moving. So theoretically, they could have pretty much any rate of a fusion or speed, if you want to think of it that way, if you adjust the temperature accordingly. But they'll always have the same ratio from one chemical to the other. So just remember, again, rate A over rate B equals the square root of molar mass B, I'm going to be lazy with the molar mass, over molar mass A. So if you want to compare rates, well, first of all, what are you really looking for here? You're given two chemicals, so you can figure out the molar masses. So you can fill in this side. And you want to figure out this ratio. Well, that's actually not that hard. All you want to do to figure out the ratio, or the easiest way, I think, is to set one of the rates to 1. Just set something to 1 and see what the other thing is. So it doesn't matter, really. I'm going to set nitrogen monoxide to 1. So I'm going to call 1 for NO and X for CO equals, and then, mass of CO on the bottom, mass of NO on top, and you would get some value, something over 1. And that would be the comparison. If it were 2 over 1, we'd say carbon monoxide is twice as fast. If it were 0.5 over 1, we'd say carbon monoxide is 0.5 times as fast. Or you could say nitrogen monoxide is twice as fast if you prefer to say it that way. But whatever number you get over 1, carbon monoxide is that many times as fast as nitrogen monoxide. So by setting it to 1, it just gives you an easy way, to solve that problem. And that's all you do. So you set something to 1, set one of them to 1, and go on from there. And again, I'm going to put 1 in the bottom in the denominator, because why would I put it in the numerator and make my life more difficult? If you have the choice, put your unknown in the numerator. It's easier to deal with. Similar for the next question, argon diffuses 2.36 times as fast as another gas, so we have that ratio. So if you wanted to start setting up, your rate would be 2.36 for argon, and then just set the other one to 1. So 1 for X, and then equals, and then this, and then molar mass X, molar mass argon. But what you did is you said, by setting it to 1, you don't have to do any more math. What's 2.36 times 1? Well, it's 2.36. It's much easier than, say, setting the unknown to 5.37. You could do it. I don't know why you would. And again, in this case, why did I put the 2.36 on top here? Because what we're really solving for is the molar mass in here, and I want that on top. That's just because it's easier. You can do it the other way. It'll still work. It's fine. It's just an extra step because you then have to invert it at some point. But this works, and I just wanted to clear those two things up. Also, the first two questions don't have mathematical answers, or number answers, I should say. They're thought questions. So the first question gives you a list of gases and basically asks you which one goes fastest and which one goes slowest. What determines that? Well, figure it out. And the other one is basically the same type of question, but gives you a scenario, and you have to figure out, based on the relative speed those things go, which one goes faster and which one goes slower, where they would meet, assuming they were released at the same time. So those don't kill yourself trying to find some complex formula for those. They're just simple thought questions. So again, this worksheet is due Tuesday night, which should be tonight if you're viewing this on the correct day. I'm probably going to put it up Monday, so maybe you'll be viewing it early. But it's due Tuesday night at 6:30, and we will have a quiz on Wednesday on all 7 gas laws. And again, for the quiz, you can use any resources except one another. Please don't talk to each other while taking the quiz or anything like that, or copy off anyone. But yes, you can look stuff up. You can use a calculator. Again, I'd rather you learn this. I want to know that you're, learning it enough that you can do the problems. It would be better for you if you really learned how to do this stuff without extra help. But that is up to you. You would always have a periodic table in my class, of course. But you're allowed to use. There's no harm or shame in using anything else to help. So with that, hopefully this helps out, clear a few things up. Good luck on the quiz on Wednesday. And if I don't talk to you between now and then, have a good break. Enjoy Easter. Stay healthy.